Hello, everybody. This is George Bai from Bai Aerospace, and we are going to be presenting on the EV aircraft development program around the E-Flyer and the FAR Part 23 development and program progress of the E-Flyer family of aircraft. Many of you are familiar with us. We've had a chance to really get to know the general aviation community, and in particular, this event has been great fun and very interesting for all of us, particularly as we talk about flight training and how we bring the next generation of pilots into this profession that we all know and love so much. My background, some of you may know, I started out flying with my parents at a very, very young age, Cessna 172. And then a little bit later, both mom and dad, as pilots, purchased a Piper Cherokee 140. And we flew that aircraft as a young family all around Oregon and Washington State. I took a couple of trips with my dad and my mother in my teen years up to Canada. Really, really fell in love with aviation. And as I set kind of the course of my life, dreamed what I wanted to be, was fortunate to finish both engineering school and then go on into the Air Force. I got my pilot license back on that Cessna 172 again, and became an Air Force pilot after that. I flew the T-38, which again, many of you know, even today is flying as our advanced jet trainer. And I trained young pilots wanting to become fighter pilots in a program called NJEPT, Euro-NATO Joint Jet Pilot Training. And that was at Sheppard Air Force Base in Wichita Falls, Texas. A great experience, but one of the things, in addition to developing me further as a pilot and then training new pilots that wanted to become fighter pilots, was the discipline and the process of training pilots with real challenges, real stress in a very advanced scenario. But it was a Euro NATO program, so I got to know a lot of our potential friends across Europe and understand the culture and the great heritage of aviation that they have in Europe as well. I went on further training into large aircraft, the C-141 Starlifter. Again, lots of pilot training, both for myself and then, of course, going to war, Desert Storm, Panama, Peru, El Salvador, and Somalia in 1993. Along the way, I became an instructor aircraft commander. So again, I was back in the training business as an Air Force pilot, Air Force officer. When I left the Air Force, continued in the training business with flight safety under a Raytheon contract to develop the T6 JPATS, Joint Primary Aircrew Training System. So again, a focus on training, development of aircraft, then became kind of part of my job as applied to the job that we were trying to accomplish. And I mention that because as we kind of accelerate forward to today, we look at developing the E-Flyer aircraft, an electric aircraft, EV aircraft, with a purpose in mind. That is, it's not a technology for the sake of technology. The E-Flyer has a purpose. We're trying to solve a problem. We're trying to address the cost of pilot training, the cost of flying, and then later as we go to the E-Flyer 4, the X, and we'll talk even about the Envoy today, what problem are we trying to solve, and how does electric aviation address the cost paradigm, the cost challenge, the cost barrier to entry, the cost as a barrier to progress in our profession. So my flight safety Raytheon time developing the T6. I went on, again, some of you know, in developing the Javelin. I spent a couple of years at Boeing on a special project to develop the advanced jet trainer with them. The TX program at the time was what it was called. And so my life has been, up until about 10 years ago, developing new aircraft, advanced training, primary training as well with a T6 program. So primary and advanced training, but all very much along the lines of applied science, applied technology to solve a problem, from military aviation and now, of course, to civil aviation. So today we're going to talk about the eFlyer EV development program, and just kind of do some light coverage. We'll try to cover some highlights I think that are interesting. From last year's time frame, we've progressed significantly, and I think you'll find this to be a very interesting update. Okay, so everybody should see now the eFlyer developmental prototype, and great aircraft. It's been flying now for 4 years. A couple of different motors over those years, different battery packs over those years. We've added significant technology, software, hardware, a number of updates, including additional battery packs, cooling system, charging port, charging station, a number of different propellers. In fact, just today, we had another flight test doing some qualification for a new 3-blade propeller. But the developmental prototype is coming to the end of its use in the development program. The critical design phase of the airplane has progressed nicely, and we're making a pivot from the developmental prototype into conformed production aircraft. Serial number 1, 2, and 3 are immediately pending. A lot of our production contracts are being signed or in the final stages of negotiation. So we're getting very close to the initial parts and pieces for serial number 1 and the conformed production aircraft, making progress with that. So beautiful developmental prototype, really has done a super job for us, but coming to the end of its program and end of its contributions to the eFlyer program development. So a family of aircraft around electric propulsion, the eFlyer 2, specifically targeted to the flight training mission, the flight training role. It's a 3-hour flight time, 2-seat primary trainer. eFlyer 4, immediately derived from the 2, to come to market shortly after the 2 as a 4-seat aircraft with air taxi, advanced training, and other business utilities. And that'll be a 5-hour airplane with 175 knot speed, the eFlyer 2 with 135 knot speed. So 135, 2-seater, 175, 4-seater, 3 hours of flight time for the eFlyer 2, 5 hours of flight time for the eFlyer 4. And then the 6-seat eFlyer X will fly even longer and faster, being lightly pressurized with retractable gear. And again, kind of providing for the ability to travel farther, faster, and higher. And of course, what's fun about that is that electricity in its propulsion and turning energy into torque does not use any combustion. There is no CO2. There is, in fact, very, very little noise. even 500 feet away, you can't hear the developmental prototype flying by. Very, very whisper quiet, about 30 dB quieter than a typical Cessna 172 or Piper Archer. But the E-Flyer X flies higher, not combusting any avgas in the process. So the electrons to torque to thrust literally is unaffected by density altitude, hot, high temperatures, climbing into the low 20s even with light pressurization. Very, very effective and efficient in converting electrons to torque to thrust, and very nice true airspeed at 25,000 feet. So a nice portfolio family of aircraft, starting with E-Flyer 2, two-seat trainer, the E-Flyer 4, four-seat air taxi, and advanced trainer E-Flyer X is kind of the ideal personal business aircraft to fly fast, high, and comfortable. But the key thing with each of these aircraft, focusing on flight training initially, the key thing is that flying with electric is all around the energy of the electricity and the electrons and the relative low cost of that electricity. As you can see, per flight hour for the E-Flyer 2, all we need is about $4 worth of electricity for a flight hour. $4, as opposed to $40 or $50 or $60 for aviation gasoline. That's fantastic. In fact, not just revolutionary, but disruptive. That changes the whole paradigm of flight. When you can dramatically lower the cost of energy, and in fact, the overall operating cost by such a margin, it changes the access to flying. It changes the opportunity for flying. And of course, when you look at pilot training, when you look at recreational or business, on-demand air taxi or on-demand air cargo, all of those paradigms and all of that business case changes with such a radical drop in energy cost. Payload, of course, matters. Speed matters. And when you match performance and the design of the E-Flyer 2, it is specifically targeted for the primary flight training mission. E-Flyer 4, more of a generalist, more of a utility, and of course with much greater payload, range, and speed. It offers not just advanced pilot training, but it offers a utility for a number of missions, to include, in fact, air taxi and even air cargo. E-Flyer X, the slightly higher energy costs, of course, as you move across from the E-Flyer 2 to the 4 and the X, but significant capability and payload. Again, there's no fuel payload exchange. No exchange, no rebalancing of the equation. It is, in effect, a full fuel payload. The weight doesn't change except for the payload of passengers or cargo. So you look at the whole, the larger whole process that we go through in developing the E-Flyer 2 in this case. It is specifically designed around the training mission, as we just mentioned, and we take into account all of the aspects of the design for that specific role. The size of the cabin, the arrangement of the instruments and the flight controls, the visibility, the outlook, the placement of the cabin and the pilot's eye as opposed to the position of the leading edge of the wing. Of course, the very great advantage, as you might imagine, out front of the airplane is a much slimmer, sleeker nose. And in fact, the overall aero efficiency of the airplane, not just its its layout and comfort and function, but the overall aero efficiency is literally twice that of a Cessna or Piper that it's replacing. We have an L over D, or aero efficiency, lift to drag ratio, glide ratio, some would say, of 20. In fact, a little bit better than 20. A Cessna 172 or Piper Archer are somewhere in the 9.5, 9.6 to 10, in that range. So a tremendous advantage when you take all of the factors around design and development around electric motors, all of those advantages synthesized, synergized around the E-Flyer 2 to start with, and you take into account maintenance costs, energy costs, and I think in an honest and conservative appraisal, we also include the utility of the batteries. We include in our operating costs about $23 per flight hour. We include a generous battery reserve. Batteries over time, as we all know with our flashlights or with our iPhones, we all know batteries over time wear out. And lithium-ion batteries are no different. They have a useful life. A useful life, by definition, is a degradation of 15% from its factory fresh condition, a degradation of 15% of the ability to hold electricity. So over 5 years, 6 years, 7 years, 8 years, maybe 10 years, the battery over time will age, and the amount of energy it can hold will decrease slowly. Not as much as in generations past, but the modern lithium-ion battery still degrades somewhat over time. The EV fleets are telling us it's a lot less now than it was 5 years ago, but they still do. So we have a battery replacement reserve built into our operating costs. So energy plus maintenance plus reserves, including battery energy replacement reserve, if you will, sum up to $23 per flight hour. And we contrast that with the Piper Archer, with the Diamond DA40, with the Cessna 172, which run between $110 and $130 per flight hour. And we have literally 1/5 the operating cost, 1/5 the flight hour operating cost for the E-Flyer 2 pilot training aircraft. Now, E-Flyer 4 is a 4-seat stretch, 850 pounds of payload, 175 knots, and 5 hours of flight endurance. It's a full IFR, full dual comm nav, Part 91, Part 135 aircraft. The motor has dual windings. We have a dual battery pack, dual safety redundancy throughout the aircraft design. Both E-Flyer 2 and E-Flyer 4, E-Flyer X all have full airframe parachutes. The airplane is designed, again, E-Flyer 2 for primary training, E-Flyer 4 for advanced training. And together with the full IFR presentation, autopilot, etc., we're able to go from the private license criteria or gate up to commercial instrument and all the way on into the ATP with E-Flyer 2 transitioning and completing with E-Flyer 4. Of course, as we know, a single engine ATP is allowed and very much a part of a potential professional pilot training program, together with great simulators, great instructors for ground-based training. We round out the total program of professional flight training, pilot training for our great customers all around the world. We have a quite a number of paid purchase deposits now. We've added many since this time last year. Over 360 paid purchase deposits now. Customers in Europe, North America, all around the world. The professional pilot training academies and universities are looking for this next generation of flight training, and the primary tool, of course, is the simulator and the aircraft to help these young people become professional pilots and join in the commerce and business of aviation. eFlyer 4, again, still 1/5 the operating costs, about $30 per flight hour. There's a little bit more maintenance on a 4-seater, as we all would understand and agree. Again, that's contrasted with the general aviation legacy fleet, the Cessna 182 and the Cirrus SR22 in this case, 143 and 165. Again, 1/5 the operating cost for the eFlyer 4. And of course, eFlyer 2 and eFlyer 4 are not just new aircraft for building up existing fleets, but they're also aircraft meant to replace legacy fleets that have come to the end of their useful life. Many of our aircraft, as we all know, were built in the 60s, 70s, and early 80s. They're on average in that 50-year-old range. I think the actual average is 48 point something years old for the single engine fleet, which is just incredible. It's incredible for, on the one hand, that they've lasted that long, and that's a testimony to such great designs, great robustness in those designs so many years ago. On the other hand, it's a crisis. These aircraft are at the end of their useful life and certainly becoming difficult to maintain, difficult in terms of the translation of the older technology to training today's generation of pilots. So there's an urgency, not just for new business for pilot training, but to keep relevant and bring the state-of-the-art technology, state-of-the-art aircraft design and function, structure, aerodynamics, avionics, bring all of that to the market for the replacement of these older conventional aircraft. And then as we look into kind of the fun future, the eFlyer X, which is a 6-seater with light pressurization, a 25,000-foot ceiling, retractable gear, and of course 240 knots at 25,000 feet and 1,050 pound payload. So a real aircraft with significant payload, speed, and range. And again, the legacy aircraft today, many of them getting very old, great aircraft like the Beech Bonanza coming to the end of their useful life, and such great technology, speed and range with the eFlyer X, addressing those advanced markets for again, cabin crew kinds of training, pressurization, retractable gear kind of training, business, air taxi, perhaps even cargo, and certainly the business, personal business aircraft, much like the Matrix Malibu Mirage, Bonanza, the series of light twins, Seminoles and Senecas and the like. So a great aircraft, eFlyer X, part of the eFlyer family of aircraft. And as you can see, as we get a little bit farther along in speed, range, weight, endurance, that the operating cost comparison gets a little bit more dramatic. The maintenance cost of the higher end piston aircraft, heavy, complex, the number of cylinders and complexity and so forth in a Matrix, Malibu, Mirage, Bonanza, etc., really brings up the maintenance costs. The fuel flow, of course, much increased. So the operating costs for these more complex singles and light twins is contrasted with, again, just a very few additional electrons, if you will. The electricity costs does not accelerate at the same rate as the cost of fuel and the cost of maintenance. So the contrast actually gets more dramatic with the eFlyer X, about 1/7 the operating costs of the light twins and heavy singles. So as in simulation, the cabin of the aircraft or the simulator needs to be designed around the mission of pilot training. And in this case, we're showing the eFlyer 2 cabin with a great Garmin-based avionics package. It's relevant. It is the latest technology. The presentation prepares young pilots for the aircraft to follow. Function, fit, safety, human factors, all of the layout that you might expect in the most modern of aircraft. The center stick arrangement allows flexibility for instructor and student position, right seat or left seat, left hand or right hand. The cabin is 46 inches wide and very nice ergonomics, pilot's eye, the lookout, all of the kinds of things that are opportunities with today's latest design criteria, together with human factors and learning processes, again, throughout the entire syllabus, with instructors taking the young students through ground-based training, simulation training, and of course, flight training. Of course, in Europe and politically here in North America and around the world, climate change and CO2 is on everybody's minds, and rightly so. From a technology perspective, we have the opportunity to go electric without compromise. In fact, with tremendous incentives in cost. And to embrace this technology also embraces a responsibility, and as a general aviation community, we can reduce the CO2 impact to our environment, and not in a little way, in a pretty significant way. And of course, there's other pollutants as well, as we know, along with noise pollution. About half of our training schools are in high density urban environments. And how wonderful for us to be able to take CO2 out of the equation. How wonderful it is for us to take noise out of the equation. So we're delighted to talk about this. I think as a general aviation community, and particularly as professional pilot trainers, this is a concern to us as an industry, but it's also a concern to us when we look at the demographics and the things that are concerning young people today. And as we invite them to come into this profession, to invite them into an environment, to invite them into an aircraft with not just high technology and low cost, which breaks down those thresholds of concern, but also addresses the aspect of CO2 and the environment in a positive way. And that's a welcome mat rather than an objection. That's an opportunity to bring a broader group of young people from demographics, from a financial background, their views and their life experiences can now, with electric, have a broader, deeper appeal than some of the concerns that we've had in the past with our legacy aircraft. So we're very, very pleased about this. It's very important, and we're delighted to work together as a community to help discuss and promote this important feature. Some in the past have been skeptical, of course, about the benefits of electric. It's kind of interesting physics, it's interesting engineering, but is it proven? Is it real? And of course, now flying for the last 4 years, we have a depth of experience with the aircraft in the real world, flying real test missions, test profiles, and we definitively can address the amount of energy it takes to fly an electric airplane. We can definitively address the recharging time and the motor and performance behavior and characteristics of the airplane are well proven. We flew, as I mentioned a few minutes ago, we flew just again today and did some propeller efficiency tests. But as you can see in this slide of the developmental prototype, this is fascinating. I mean, look at this. At 9,000 feet density altitude, using about 90 horsepower, we're still climbing at 640 feet per minute. And just think about that a second. 92 horsepower, 640 feet per minute rate of climb. At sea level, a Cessna 172 climbs at 740 feet per minute on 160 horsepower, or a newer 172 on 180 horsepower. So twice the horsepower for a Cessna at sea level gets about the same rate of climb as what we're doing at 9,000 feet and 92 horsepower. A tremendous illustration of the aero efficiency of the airplane and of electric motors and the electric propulsion system. So the overall aircraft design, much more efficient, much lower drag, much higher aero efficiency, but also the propulsion efficiency is higher with less cooling drag, and of course, more exposed propeller blade area. The entire propeller blade is exposed to the free air. The entire propeller blade's providing thrust rather than the first third or so providing cooling for the internal combustion engine. So tremendous advantages from design and performance and the electric propulsion system efficiency, as well as the overall aero design of the aircraft. About 40 horsepower for 90 knots true airspeed cruise, 60 horsepower for 120 knots true airspeed cruise. Just a fantastic conversion of energy to performance. And you can see in the production E-Flyer, as we go from developmental prototype to full conformed, production conformed aircraft, we increase in that performance even further. So the production aircraft is next. The developmental prototype has pushed the envelope for us, demonstrated performance, demonstrated capability. The batteries are well known, motor performance is well known, battery management system, inverter controller, motor, all of that working together in harmony together with an advanced aero design, proving for us, proving for the industry, proving for our customers, and most importantly now, proving for the next generation of pilots that we're ready to present a certified pilot training aircraft, first in the E-Flyer 2 and next in the E-Flyer 4 and the X and on. Well, a quick peek at what comes next. And of course, as we all know, the future will include heavier, faster aircraft, both for the pilot training requirement, for the multi-engine aspect, the last 25 or 50 hours, and sometimes more, of obtaining your ATP license usually involves multi-engine. Sometimes we kind of reach back and try to include more Seneca or Seminole time. There are other programs that use other aircraft like the Diamond, for example. But nevertheless, to some extent, we try to include some twin motor or twin engine time. So the multi-engine training and readiness for that is included in the final maturing stages as we get closer to 1,500 flight hours for the ATP. The Envoy, as you see here, is a twin and potentially adds to that portfolio of training to take us all the way through a regional turboprop kind of all-electric aircraft. And of course, beyond the training role, the air taxi and regional transport role. So the Envoy, very exciting part of our future. We're looking forward to announcing that program officially here very soon with a number of customers and partners. But as you can see, we're very excited about the E-Flyer. The benefits of electric and the high technology opportunities that electric brings to the table are absolutely amazing. There is no technical hurdle remaining in bringing to market a FAR Part 23 fully certified electric trainer. Our relationship with the FAA has been fantastic. All of our Tier 1 suppliers are transitioning now from development into production agreements for the E-Flyer 2 and to some extent even for the E-Flyer 4. We're going through the system-specific certification plans. There's 14 of them with the FAA. Those plans literally lay out the transition from a conformed design that we have now completed to the process of evaluating each of those components or systems and on a real production aircraft, proving that the production aircraft does indeed conform to what we expect from the conformed design, production conforming design. So system-specific certification plans are kind of that transition checklist. What we show with production conformed aircraft, serial number 1, 2, and 3, particularly 2 and 3, will be used as test articles with the FAA to demonstrate each of these 14 specific criteria and the checklists against each of those criteria structures, for example, avionics, cabin, safety systems, the electric propulsion system, and so forth. Each of these major areas of the aircraft will be evaluated against the criteria in each of those 14 system-specific certification plans. And so we're working together with the FAA to finish those criteria up, so we have an agreement about how we'll proceed and evaluate the production aircraft. We expect literally in the coming few weeks to make initial announcements about the production conforming aircraft and the launch of the assembly, construction of parts, the various production, Tier 1 production suppliers. It's a very, very exciting time. In conclusion, I couldn't leave this conversation about electric aircraft without embracing and discussing the obvious. I mean, we're doing this presentation today via recorded conference. It's a video. We're not here face to face, and our industry is challenged with the coronavirus pandemic and all of its impact. Of course, we have been impacted. All of you have been impacted. Student training, the throughput's changed, the timelines have changed, the airline demand profiles, airline activity, transportation industry as a whole has all been impacted by the coronavirus. So in conclusion, certainly we see today just a gigantic impact, and it's tragic, it's challenging, but I believe we've got grit in this industry. Buy Aerospace has the courage to face this challenge and the team to face the challenge. Great tier one suppliers, great regulator partners in the FAA. Our friends around the industry are showing the same courage to face this challenge. And yes, this coming year, perhaps the next 2 years and even 3 years, we'll continue to see the impacts of coronavirus continue to weigh us down and to be concerning in so many ways. But we all know, by Aerospace, all of our suppliers, all of you, our friends at the FAA, we all know that there's a light at the end of the tunnel. There will be an end at some point to this pandemic. And we will see on the other side of it, the economics, particularly the demand for new pilots, reemerge. In the 2 to 3 year time frame, we should be in production with the solutions to provide the new tools, like all of you are, to provide the new tools for the next generation of pilots that will come on board as the demand for new pilots begins to reemerge. In that 1, 2, and 3 year time frame, part of using this time wisely is to make all of the preparations as best we can, working together with all the resources and friends in the industry as a whole to achieve readiness, get through the challenge today, but to achieve the readiness as the demand returns in the next year, next 2 years, next 3 years. What I like to say in conclusion is that this is indeed a community, and that we all collectively can emerge on top and meet this challenge. Whether it was coronavirus or any business acceleration or any business retraction or reduction, the general aviation community is known for its collective endeavors. I congratulate and I'm thankful for this time to be able to speak to you, but I speak to you as a community, and I know we all look back and forth amongst ourselves to challenge each other, to encourage each other, to support each other, and to work together as a team for the common benefit of the industry we all love. And the bottom line is, when it's our turn now. We want to be able to reflect back on this time, knowing that we did the best we could, and prepare the next generation for the future that lies ahead. Again, thank you so much. We are honored to have been a part of this presentation, and we hope that you enjoyed this PowerPoint and the update on the eFlyer program.